Hello, welcome to my channel Code Design. In this session, we will discuss about designing a hash map and we'll be implementing it. So, what is a hash map? So, hash map, you all know, is a key value pair that we can store on hash map. It's a data structure where we can store key value pair and retrieve value based on keys efficiently. um, um, is basically on O1 runtime for storing a key, for getting a key, and also remove a key. Everything is O1 time complexity. So let's see our requirement. There, this we can have the similar problem from Leetcode 706 that says design a hash map class named my hash map and implement the below methods. So though this can be solved in a very easy way, but since this is a design object-oriented design session, so we'll be doing it correctly and efficiently and the way it should be instead of going a very easy way just to solve the lead code thing. So what we have to implement, we have to implement a put method that takes key and value, a get method that takes key, and a remove method that takes a key as input and remove the element or the key value from the hash map. Let's look at the HashMap internals, how we can represent a hash map. So, in order to store the keys, right, we can think of arrays as we can call it buckets. So, bucket 0, bucket 1, and this is the example of a hash map having 10 buckets from 0 to 9 index, and each of the bucket will refer to a node of a hash map. So I'm not telling the whole linked list. There is some more things that we need to consider. So let's look at this. So bucket, right? I already said that we are considering each element of the hash map that will store the hash map as a bucket. And what is hashing? So we need a hashing algorithm to map the hash map key to a index of this bucket. So if our key is integer, it is very easy. We can map the integer key to any of the index by taking a mod of the size of the map or the initial capacity or size of the array. But if this is an object, not a key, then we need to get the hash code of the object and which is the integer, then take the mod and convert it to index. Capacity, what is the capacity? So in this problem, we will be not handling capacity. So we'll take the array size of 10,000. But for real hashmap implementation, it starts with an initial capacity of 16. That means there are 16 elements in the initial array. Then the array resizes. So the array gets double when there is a threshold. So what is that threshold? Is a load factor. So load factor means if we have 16 elements here and 12 of them is already filled with nodes or key values, then we can say 75% load factor. That means it's time to resize the array and make it double. So this is how, as we get more data to store on the hash map resizes its array and copy the data and also reindex, right? It rehash the elements to fit in the new array. We're not going to handle those things here. And then threshold, what is the threshold? Product of current capacity and load factor. So if our current capacity is 16 and load factor is 75.75, then the um, the threshold would be 12. That means when 12 element is already filled, we need to um, resize the hash map, the array. So collision, right? We know now what is rehashing. Recalculate the hash and put the nodes on the new array on the right place, and then collision, right? What is a collision? When what happened here, if we so the size of this array is 10, and so whatever is our key, if we mod by 10, then what happens? So say 2. If it is 2, and if it is 2, and we take a mod by 10, it will be 2. And if it is the key is 12, and we take a mod by 10, it will be also 2. So similarly 22, right? It will be also a mod by 10 too. So all of these should be in the same bucket. So then if all of them in the same bucket, what are the ways we can, so that's called collision, right? So how we resolve collision, we can resolve collision with chaining. So this is the thing that linked list is coming here. And so before Java 8, it was implemented by like this chaining with a linked list. And from Java 8 and above, it do a mix of chaining and a linked list and a binary balanced binary search tree called red black tree for collision resolution. So what happened on a red black tree, if the element is more than 8 element here for the same index, instead of a linked list here, it creates a red black tree. So why is that balanced tree? So instead of on, so if all the elements goes here, then it will be actually on time complexity to retrieve the element. If we use a balanced binary search tree, it will be log of n to store the data or retrieve the data instead of n in case everything is going here. There is also a technique to handle collisions like it's called linear probing, quadratic probing. So there that basically does if there is multiple entry going to the same or so many entry going to the same bucket, it tries to assign it to a different bucket with some algorithm. So let's move on. And so what are the for collision resolution, can you use chaining? Yes, we can use chaining here. We'll not go here the complex red black tree. And do we have to worry about load factors, capacity, and rehashing? Here we'll not be worrying about this. Do we need to handle thread safety? No. For making it simple, I'm not going towards thread safety. And constraints, since we are taking it from Leetcode, so the key would be 0 to 10 to the power 6, and that means 100,000. Key and value range would be 0 to 100,000. There is a mistake here, it should be 10 to the power 6, and at most 10,000 calls will be made on the hash map. So the hash map we will design, we'll run it on Leetcode to see how it performs. You know, and the lead code will make at most 10,000 calls. So that's why we'll be making this array size 10,000. So there is an example here. These are put, get, and remove calls, and so we're not going to the examples right now. But let's look. Yeah, we can actually see the example. So what happened, or maybe better to look it here. As I said, say two comes, so we take a mod by 10 and we make it here. This is the first entry in the bucket 2. What happens if another element come 12? We mod it by 10, we get 2, and so we create a new node of the linked list and point this node to this node. So this is how we started building a list. Is we instead of using a full linked list implementation, we can just add a single node of a linked list in for the index and then keep adding them. So basically, this node 2 will have the reference for a single linked list node, and then node will refer to the new one for chaining. So what happen if 16 comes? We mod by 10, so we get the index 6 and we store here. And now if there is a get, if there is a get and which is 4, we mod by 10, then it goes to the index 4 and there is nothing is null, so we return -1 because the requirement is if nothing is there, return -1. So if 29 comes, we mod by 10, and 29 mod 10 equals 9, and we keep it here, and the same as 39. Then we see already there is an element, so we create a new node and point this first node to the next node. So we add at the end of this list. So we this is a better example than the one we have. You can see this example. I will be giving the website link as well. So let's see what will be our how the node will look like. So the node for this hash map will be like this. It will have a key and value because we'll be storing key and value and a reference to the next node. So that will be our node class or node, and initializing, we are not actually initializing the array for making it efficient. See, we are using a 10,000 element because we are not considering rehashing or capacity increase. We are initially having the array with a full capacity, so I don't want to initialize each of every element of the array with a node, which will be a bit inefficient. Instead, we when we create this array of node, uh, all of the element or all of the bucket will be initialized at null. So and let's see, look at the get method, which is the easiest one. And so get take the key as input and call the hash function. What the hash function does, the hash function simply take the hash code of the key and then mod it by size of the bucket. So since our in our requirement our key is integer, we could just do this key percentage size, but I kept this thing getting hash code because this is a standard practice, because most of the time you might have an object or a string for key of hash map, and then you need to use the hash code to get a integer value so that you can convert it to index. So on our get, we call the hash on this key and find the index where we need to search for the node key value pair. So this is our bucket array. So it is trying to find the element. And what happened initially, as I said, everything will be null, right? So initially it will be null, and nothing is there, but when we are calling, if it gets null, right, while node not equals null, so it will not enter here, it will just simply return -1. But if we have the key exist in the bucket, then it will get a node, and what we are doing, In case if it is a fast node, then it will say node not equals null, and if node dot key equals key, it will return the node dot value. Fast node of the chain or the linked list. If not, we'll keep looping through the linked list, keep moving forward to the nodes to find the element. So that means here we will see if it exists. So it is the first element. If this is not, like to get 39, we will not find it at the first element. So we need to move next to the next element and get the element 39. So get is good, and so it returns the key or returns -1. Let's move on to put. So this put will handle both insert and update, and let's see how it works. It will do the same thing. It will do a hash on the key and get the index, and with the index from the bucket array, it will get the node. And what if the node is null? That means there is no linked list yet for that bucket. So we will create a new node with the q and value, and we'll store it on that index for the bucket, and we'll return. So that will basically insert the first element, and create a node and insert the node in the bucket index. Okay, so what if we already have this node, then we have to update it, right? So let's see how the update will work. And there is a thing previous node, so it will require for a use case to insert at the end of the node. So let's not worry about this now. So let's see how we'll go through each of the node and see if the node the key matches, right? So we do while node not equals null, and we do node equals node dot next. We can actually move it to IntelliJ for this. So here we are here for the put. So what we'll do, let's not think about previous. We do it here, and we take off this thing. So basically, or we just look at these things. We are saying while node not equals null, then node equals node dot next. So we are keep moving, and we will be checking if node dot key equals key. We'll update, simply update the value and return, because put is updating the value. If not, if doesn't match, then we will simply move to the next node and we will keep the previous node. So this is what we are keeping the previous node. Why? Because think about the last element. So if we don't have, so say we have to, so on a bucket of index, say index 2, we have element 12, 22, and 32. And in the put function, we want to insert 52. So what will happen? Um, it will keep moving forward. It will first get the index 2, and first element is 12. It doesn't match, so it will move to 22. It doesn't match 32, and then it is still doesn't match. So it will come out of the loop, because the node is now null, because we are here after 32. So since it did not get the key in the linked list, so it will insert 52 at the end. So that's what we are doing here. Previous would be now 32, and so previous dot next, that means 32 dot next, this node will be our new node. We create a new node with key value. Key is 52, or value in any value that we have. So this is our put method. And we have a remove method here. So remove method will also do the same thing. It will take a hash to get the index, and it will find the node from the bucket or from the array at that index. And for deletion also we need to get the previous node, because what will happen in deletion? Deletion basically we can move back to this thing for deletion. So if we want to delete 39, then we have to find the previous node, right? Previous node is 29. So we need to say previous dot next. We need to say previous dot next equals um, node dot next. So we want to remove 39. So node dot next will be null. So previous dot next would be null. So this is how we can remove this node. And what happen if we want to remove 29? If we want to remove 29, again we need to so in this case previous is null, because there is nothing before 29. 29 is the first node. Then what will happen? This bucket position we need to say bucket of 9, bucket of 9 equals node dot next. So we want to delete 29, so node dot next will point to this 39. um, will point to 39, node dot next. So this is how we can delete the first element. So let's move back to our code again on IntelliJ. So uh, yes, so here we were on the remove method. So this is the case. It keeps the previous, and what happened if node not equals null? It check if the node is the one we want to remove. If this is the case, then it checks if previous not equals null. If previous not equals null, that means we are removing node maybe at the end or in the middle, not the first node. Then it just say previous dot next equals node dot next. And if previous is null, that means the first node will be removed. So we want to remove the first node, and this is what I have shown on the diagram, that bucket of index equals node dot next. So we will make the first node of the linked list point to the next node. This is how we'll be deleting the current node. And this as well, this is keeping the previous, and this is making the loop forward while loop. So for testing, we have these things. We have this is easy. The key value 1 1 2 2, and it is then inserting 1 1, inserting 2 2, calling 1. So since we have already 1 as a key, it will return 1. Then calling 3, we don't have a 3 here, right? We don't have a 3 as a key here, so it will return -1. It is putting 2 key and value is 1, and calling 2, it will return 1. Again, it is calling a remove with the key 2, and the key will be removed. And then again it is calling the get with 2, and it will return -1 because we just removed the key. So now that we are done with this, let's see on the Leetcode. So I have copied the code here and let's run it. Okay. The simple test case run for this one, and if I submit, it will also run because I have submitted the same code here. I'm not going to click it again because it's the same code, but I will show the performance. So time complexity, right? It beat 99.59% of the submission, and it is very efficient, one of the best efficient, 14 millisecond. Why it is so efficient? Because I'm not even using a built-in linked list. I could use a built-in linked list to create a hash map. If I use a built-in linked list, it will have more complexity. So instead of keeping the whole linked list in the memory, also I'm just keeping the first node of the linked list, the reference of the first node, and chaining the node. And memory wise, it is also efficient. 57, it beats 57.53% of the submissions of the hash map. So this is a very popular interview question. This design and implement a hash map, and for small, mid tech to big tech, all kind of company, and they ask this question. So this is a very important question, and what they want you to understand how you can build it from scratch this way. So I hope this video will be helpful. Let me know your feedback, how you think about this, or did you like it or not.